Hi, and welcome to my part 2 of my video about STEM tools and how to use them in education. So I'm going to share with you the screen about the video of the lab that I designed to become a smart maker lab. So I'm going to share the screen with you. And so I designed a lab using a program called SketchUp, and I'm going to show you the screen. I'm going to try to flip the whole screen so you can see the whole thing. So I designed a small lab, and this lab would be my dream lab for teaching STEM. I'm going to take you inside the space. It would be a computer lab with maybe 15 to 12 stations. The lab would have a smart board in the front, and would also have several 3D printers. And in the smart board, we can use it to teach all kind of tricks about the program, how to use software, and how to use software and 3D printers. I'm going to go back for a second. So the way this room is laid out, as you can see, this is my whole STEM approach to teaching. I want the students to ask smart questions, think of brainstorm solutions, and then try to plan, draw diagrams, then use the computers with programs like SketchUp and Tinkercad to design their approaches. Then we can use the 3D printers to print the product, and then the product would be evaluated, and more questions could be asked, and the process would be revised to get better and better. So this is our entire approach to STEM education. I'm going to show you the rest of the lab. So the idea was, because 3D printers are slow, we will try to acquire as many 3D printers as possible, maybe have 5 for each student, and use laser printers as well, laser cutters, to produce objects and artifacts. And I'm going to go to Prezi in a minute and discuss how we're going to approach the design and construction of this lab. The way I designed the lab, as you can see, is a U-shaped lab where we have a conference table in the middle where students can, after attempting their work on a computer station, come to the center island and either print the products or sketch and draw and discuss as a team of designers what their product is going to be like. And so this is my space, and this is how it's going to be like. Then I'll share the screen, share screen. I'm going to share my Prezi. Is it on my code? Where is my Prezi? Okay, this is my Prezi. And when I was doing the research for my paper, I realized there's 5 challenges that might affect 3D printers in the classroom. One major printer was the price of printers and the equipment we can use in the lab. And to solve this problem, I proposed getting a grant and using the money to buy as many printers as we can possibly have for this classroom. Second challenge was that most science teachers don't have enough experience in using 3D printers and CAD software. So we have to use summertime for training the teachers to become more prepared to do this kind of education. One challenge that came up was that most computer labs, most 3D printers are slow, and it will take sometimes an hour to print one object. So I proposed buying more than one printer for the classroom and using downtime, whether it's lunch break or evenings and after class, to print the objects. So the objects will print overnight, and the students will come the day after and have them ready. The last thing is, in STEM education, is really challenging that if you have open-ended questions and projects that are not conclusive, maybe a student might try to design a project that's ambitious and may fail at it. And most of our education system uses similar rubrics to grade assignments. So I'm proposing designing rubrics that will grade the students based on their efforts and the results. So if someone is doing something really challenging and may fail at it, they still make it a good grade, which is something hard to assess in science education. The last thing that's I'm thinking about is some people think 3D printers are dangerous because the machine is hot and it's moving, and if a child puts their hand through, it could hurt them. But they're designing now 3D printers that are safe and they're enclosed and they're designed with child safety in mind. So these are the challenges that I was hoping to address in my course. And I'm going to end it here.